The Faroe Islands are an archipelago set between Norway and Iceland. Because these islands are so remote, historians believe they were one of the last places on Earth to be settled by humans. The most popular theory says that the Vikings were the first to settle the Faroes, arriving sometime in the mid-9th century. But some researchers think that the Faroes could have been settled much earlier, by an unknown group of people. And how do they know? Why, a volcanic eruption from centuries ago, of course. Studying early human migration doesn't just help us understand the history of our species, it also helps us understand the effect that humans, even pre-industrial ones, have had on the natural environment. Since the Faroe Islands were settled so recently, the picture is clearer than in most other places. Now, there is some prior evidence that humans were in the Faroes earlier than we thought. We don't have much in the way of direct physical evidence like artifacts and remains, so we've had to turn to some more tenuous lines of evidence. A study published in 2013 showed that ash patches in the Faroe Islands contain the remains of barley grains, a human-cultivated crop not found in the wild, from as early as the 4th century. But on its own, that doesn't amount to proof. The same can be said for studies of how the Faroe Islands ecosystem has evolved over time. They demonstrate significant environmental change before the 9th century, going from heavily forested to mostly grass. Now, humans have always been very good at making huge environmental changes to the land that they settle in, harvesting wood from forests and clearing space for farms and livestock. But again, the evidence is circumstantial. Sure, humans could have caused those changes, but so could other natural factors. So none of that really tells us humans were present on the Faroe Islands before the Vikings and driving their environmental change. But archaeology isn't all dusting off bits of broken pots. A study published in 2021 presented way more conclusive evidence, and it got a big leg up from geology. This evidence was hidden in layers of volcanic ash, deposited from ancient eruptions 700 kilometers northwest of the Faroes, in Iceland. 700 kilometers isn't that far away on a global scale. That's about the distance between New York City and Detroit. And volcanic ash can travel a long way, especially from large eruptions. In 2010, the eruption of a volcano in Iceland grounded flights across the European continent, much farther away from Iceland than the Faroes are. Which means ash wouldn't have had any trouble reaching the Faroes, and leaving evidence for geologists to interpret. Now, volcanic ash is actually made of microscopic shards of glass, which are projected into the atmosphere every time a volcano erupts. When that ash eventually falls out of the atmosphere, some of it ends up at the bottom of lakes, forming distinct layers of lake sediment that are clearly volcanic in origin. These layers are called tephra, and every eruption has its own distinct chemical signature, which is locked into the tephra like a fingerprint. Chemical analysis of tephra can tell researchers where an eruption took place. More than that, if there are other records of that eruption, you can work out when that eruption took place. Normally, matching a sediment core's layers up to actual dates is a difficult process, requiring intensive dating methods. But using tephras can shorten the process. Because every tephra signature is unique and comes from a separate eruption, once you know the date and chemical signature of an eruption anywhere in the world, you've basically got a number corresponding to that layer anywhere you find it. When researchers looked at a sediment core pulled from a lake in the Faroes, they found 10,000 years worth of sediment layers. Most of it was normal sediment that comes from erosion and rain. But hidden in those sediments were several tephra layers, and one of those was the Landnam Tephra. The Landnam Tephra had already been linked to an Icelandic eruption that happened in 870 CE, only a few decades after the arrival of the Vikings. And decades are pretty minuscule on a geologic timescale, so in a core like this, we can say that the Landnam Tephra marks the moment when the Vikings arrived on the Faroes. If the Vikings were really the first settlers, there would be no evidence of human activity in parts of the sediment core older than the Landnam Tephra. But deeper in the sediment core, about 300 years before the arrival of the Vikings, researchers found traces of sheep DNA. Sheep aren't native to the Faroes and were introduced by settlers, so this finding shows that humans lived in the Faroes sometime around 500 CE. So the Vikings weren't the first people on the islands after all. We still know very little about those first settlers, though. We suspect they could have been from the British Isles, but we aren't sure if they were around when the Vikings arrived or what happened to them. But the discovery answers other questions, like how the environment of the Faroes changed so drastically. Humans modified the environment with their livestock. The new results can help archaeologists reconstruct the timeline of human history far beyond the pharaohs. Researchers can use the same techniques to help map global migration, especially in places where there are no remains left behind. It can also help paleoclimatologists and other scientists understand how quickly humans can reshape natural environments, and whether a past environmental change was caused by humans at all. Which is a lot to learn from one little archipelago. Not just that this mysterious group of folks managed to beat the Vikings somewhere, but just how much geology can tell us about archaeology all the world over. Thanks for watching this episode of SciShow, and a huge thanks to the patrons who helped us bring it to you. We've got an awesome community, and if you want to check them out and see what it's all about, you can head over to patreon.com/SciShow.